All right, let's measure the cutoff frequency of a first order low pass filter. I've got it wired in dead bug configuration. I've already kind of found it by setting the function generator, but I just want to show you how to do the measurements. So you would click on or press quick measurement, and some scopes are a little bit different. Sorry about my finger there. And it's got some measurements already, but what you do is you want to measure the frequency. You click on source 1, then you move this knob and then just say measure frequency. Then you need to do measure the peak to peak of that, because some scopes don't have a ratio. So I'm just going to say measure source 1, then I'm going to move it to, where's peak to peak? Amplitude is fine. No, I want peak to peak. Oh, there we go. Peak to peak. And just click measure peak to peak, and I can get a value there. And now I need the peak to peak of the second waveform, so I click source, move to 2. I'm going to measure the peak to peak of that. And so now I just have to take the ratio of those two and then take the log and multiply it by 20. Not sure if you can see, but I got a 20 input sine wave, and so the 3D point is actually at 14.4. And then the last thing we need to do is measure the phase. So I want to measure the phase. I'm going to go from here. Now phase is from 2 to 1 or 1 to 2. And I'll just click measure, and then the phase is from 2 to 1, and so that's minus 44. Not quite sure if you can see it. All right. Now that is for finding the 3dB point. So that's 1 point on a Bode plot, right? The magnitude and the phase. Now I want to show you how to do the rise time. So we switch to square wave, and essentially I'm not being able to go all the way up to where I need to go. All right, so I need to increase the frequency of the square wave to where it really flattens out. Otherwise the measurement won't work. You can even see this little tiny peak there, which is due to the fact that the capacitor does have an inductance. So I want to measure the rise time on source 2, and I just measure rise time. And the mean is 33.5 microseconds. All right. Now, multiply that by 0.455 and you get tau. But what I want to show you is that if I get the period of the square wave wrong, I'm still getting a rise time measurement, but in this case it's 16. But it's obviously looking more and more like a triangle wave. In fact, it's actually starting to act like a pulse width modulated DAC. So you keep increasing that frequency until you get a stable value. Whoop. I want to clear the statistics. Okay. So the current is what it is. The mean will keep track of everything. So sometimes you have to press reset when you do that. But that's pretty much how to measure tau on a oscilloscope. You could try to find 5 tau that way, but it's pretty hard. Now you might be wondering too, why are my waveforms nice and sharp? That's because if I press acquire and then move this knob, that's normal, peak detect and averaging, and I have about 8 averages. That's how I'm getting away with that. All right.